Well, this is the first of two videos for the last section in Chapter 1, Section 1.9. So I'll go over the first part of Section 1.9 in this video, and then I'll do a separate one for the last part of Section 1.9. So this is about using these ideas of algebraic fractions or rational expressions to solve equations that involve algebraic fractions. So for example, let's see here, if we look at these, I'm going to do problems that are on page 73 over to 74, and then in the second video we'll finish up over on page 75. Problem 2 starts out as x plus 6 over x equals negative 7. Now there's a lot of different techniques that people use to solve equations like this that are all actually really the same thing. And they all involve sort of clearing out the denominator, right? If you remember when you were, you may or may not have solved equations like this in the past, but if you had equations that said something like, you know, a over 3 equals 5, you could get the a by itself by multiplying on both sides by 3 and getting an answer of a equals 15. So that's the idea here, is that we want to clear out this denominator right here, which happens to be x. And we're going to do that by multiplying on both sides of this equation by x. Over here it's pretty straightforward. It's just negative 7 times x is negative 7x. Over here this x has to get distributed into the parentheses. So I'll write this out, x times x, and then x times 6 over x. This is just x squared. Here the x's cancel out and we get x squared plus 6 equals negative 7x. We can add the 7 over here, and that gives us x squared plus 7x plus 6 equals 0. Now this is factorable. You can also run it through the quadratic formula. Let's see, if we wanted to factor this, it would be x plus 6 times x plus 1. So x should be negative 6 and negative 1. And if we run this through the quadratic formula, let's see here. Yeah, negative 6 and negative 1. Okay, so that's the first technique that we can use to solve an equation that has a fraction involving the variable, is to multiply on both sides by that denominator, and then that just gives us a regular quadratic equation, which we can solve either by factoring or by using the quadratic formula. All right, let's look at a couple more examples here. Let's see, problem 4 is very similar. We start out with 7 over a plus 1 equals a. And so again, we're going to use the same trick here. We're going to multiply on both sides by that denominator, which is a. So over here we'll get a squared. Over here, I'll write this out again. All right, we're going to distribute this into the parentheses. So this will just be a. Over here, the a's cancel, and you get 7. And so let's move everything over to the other side. So 0 is a squared minus a minus 7. Now this one's not factorable, and so we have to use the quadratic formula here. And so we get a is approximately 3.193 or negative 2.193. Okay, so that's the first type of problem that we're going to look at here, is a simple denominator that we can just multiply on both sides to clear out the denominator. The next group of problems are set up as a fraction equal to a fraction. So in problem 6, we have 4 over 3n plus 7 equals 1 over 2. So if you have your equation in this format where you just have one fraction equal to another fraction, you can cross multiply. So I'll go ahead and do that first. 4 times 2 equals 1 times 3n plus 7. Okay, so that's the process for cross multiplying, is that you multiply these two and say that it has to be equal to those two. So why does that work? Well, let's see. If we have, let's say we've got two fractions, a over b equals x over y. If we just cross multiply, we'll get a times y equals b times x. All right, that's the purpose of cross multiplying, is that it gets rid of the fractions for us. And notice that we don't have any fractions here or here. Now, why is that true? Why is it okay to cross multiply? Why, if this is equal, do these two have to be equal? Well, we can back this up and go through the steps, right? We just talked about multiplying on both sides to clear out a denominator, right? And then here we can multiply on both sides by y. And so there's ay equals bx. So that's what I was saying at the very beginning of this video, is that all these techniques, all of them really just go back to multiplying on both sides by the common denominator. Okay. All right. So we can cross multiply here, and that'll give us 8 equals 3n plus 7. Subtract the 7 over here. 3n equals 1. And so n is equal to 1/3. Okay. That's pretty straightforward. Let's look at a different one where we have to cross multiply. Let's see here. Problem 8. Y minus 2 over 2 equals 5 over y minus 5. All right, so again, we've got a single fraction on one side, a single fraction on the other side, so now we can cross multiply and say y minus 2 times y minus 5 equals 2 times 5. So that's 10. Over here, we get y squared, minus 5y and minus 2y make minus 7y, plus 10. Subtract 10 on both sides, and we get y squared minus 7y equals 0. Now this is factorable. This is y times y minus 7. And so we can see y should be 0 or y should be 7. You can use the quadratic formula on this as well. You would say a equals 1, b is negative 7, and c equals 0. And then that would give you these same answers of 0 and 7. Okay, well, that's problem 8. Let's see, let's look at number 12. We've got a over 8a plus 3 equals 1 over 3a. And again, if we just cross multiply, 3a times a is 3a squared. 1 times 8a plus 3 is just 8a plus 3. And then we'll move everything over to the left-hand side. So this is 3a squared minus 8a minus 3. I think this is factorable. We can run it through the quadratic as well. Let's see here. Okay, oh, let's see here. 3 minus 8 minus 3. There we go. Yeah, and so this says a equals 3, or a is negative 1/3. And if you wanted to factor this, let's see, you would put 3a here, 3 here, 1, 1a, and what do we want here? Negative and positive. And so there's your a equals negative 1/3, and there's the a equals positive 3. Okay, so that's problem 12. Now they get a little bit different. So let's look at problem 14. So 14, we start out with 1 over x minus 2 plus 4 over x plus 5 equals 1 over x minus 3. Okay. So in this scenario, we don't have just a single fraction equal to a single fraction. On this side, we do. We have a single fraction over here on the right-hand side. Here, we've got two separate fractions. So what we're going to do here is we're going to add these fractions together, which means we have to make a common denominator. All right? And then we'll have a single fraction over here, a single fraction over here, and we can cross multiply. So let's go ahead and do that. So to make a common denominator, these are both prime, and so we just multiply each one by the other. Okay. So our common denominator is going to be x plus 5 times x minus 2. Up on top, we get 1 times x plus 5 plus 4 times x minus 2. Okay. And so let's see, what is this going to be? X plus 5 plus 4x minus 8. So that's going to make 5x minus 3 over x plus 5 times x minus 2 equals 1 over x minus 3. Okay, so now we're going to cross multiply, and we're going to say 5x minus 3, right, because we have a fraction equal to a fraction, so we can cross multiply. 5x minus 3 times x minus 3 equals 1. We don't need the 1 in this case, but if it's not a 1, you will need whatever number that is, times x plus 5 times x minus 2. All right, so this will be 5x squared, let's see, minus 15 and minus 3 makes minus 18x plus 9. And then over here, x squared plus 3x minus 10. So let's move all of this over to this side. So these all cancel out and make 0. Over here we get 4x squared minus 21x plus 19. Okay, so let's run this through the quadratic and see what we get here. 4 minus 21, positive 19. We get x is approximately 4.088 or positive 1.162. So there's our solutions for problem 14. So just to review what we did here, right, we had a single fraction over here, so we just left it alone. Over here, we took these two fractions, made a common denominator, and added them together. Now that we've got a fraction equal to a fraction, you can cross multiply and then solve the quadratic that comes out of it. Okay, let's see here. Let's look at one or two more of these. Problem 16, we start out 1 over y minus 2 minus 4 over 2y plus 5 equals 6 over y minus 1. So, similar scenario, just a single fraction over here. Here we have two fractions, so we need to make a common denominator for them. And that common denominator is going to be y minus 2 times 2y plus 5. So, to create that common denominator, this one has to get multiplied by 2y plus 5 over 2y plus 5, and this one gets multiplied by y minus 2 over y minus 2. So our numerator here, I can write the 1 or not write the 1, it doesn't matter. If it were anything other than a 1, it would be important to include it. Here we'll get minus 4 times y minus 2. And this one stays the same. Okay, so again, this is 2y plus 5 minus 4y plus 8. So this will be negative 2y plus 13 over y minus 2 times 2y plus 5 equals 6 over y minus 1. Okay, so now again, we've got a fraction equal to a fraction, just a single fraction on one side, single fraction on the other side, and so we can cross multiply. Negative 2y plus 13 times y minus 1 is equal to 6 times y minus 2 times 2y plus 5. So let's see, this will be negative 2y squared, and then plus 2y plus 13y, so that makes plus 15y, and then minus 13. Over here we get 6 times 2y squared plus 5y minus 4y, so that's plus 1y, and then minus 10. So this one stays the same. Over here we get 12y squared plus 6y minus 60. So let's move everything over here, and that'll be 14y squared. 6 minus 15 should be minus 9y, and then negative 60 and positive 13 should be positive 47. Okay, so that does not look factorable. Let's see what happens when we run it through the quadratic here. A is 14, B is minus 9, C is 47, and we get a complex valued answer. That's fine. X in this case is 0.321 plus or minus 1.804 I. So there's our two solutions, and if we wanted to plug them back in, we could check our answer as well. Okay, let's see here. Right, okay, so now we're going to look at problems 18 and 20, which are similar to these ones that we were just talking about, but a little bit different. So let's take a look at those. All right, problem 18 starts out 1 over 2x minus 1 minus 2 over x plus 7 equals 1. Okay, so what's different is that over here we don't have a fraction anymore. There's a couple different ways that we can think about this. One is just make it a fraction, just put it over 1. Okay? So if we do that, then we're still going to do the same thing that we did over here that we did in those other problems. We're going to make a common denominator by multiplying each one of these denominators by the other one. Okay, so now our common denominator is going to be 2x minus 1 times x plus 7. Up on top, we'll get x plus 7, and then minus 2 times 2x minus 1. So, let's see. This is x plus 7 minus 4x plus 2. So what do we get? Negative 3x plus 9 on top. 2x minus 1 times x plus 7 on the bottom. And then now we've got a fraction here and a fraction here, so we can cross multiply. So negative 3x plus 9 equals 1 times 2x minus 1 times x plus 7. I kind of left out the 1s. In each case, these were getting multiplied by 1. All right, so there's that. This will be 2x squared, let's see, plus 14x minus 1, so that'll be plus 13x minus 7. Let's move everything over to the right-hand side. Let's see, that'll be positive 16x. And if we subtract the 9, that'll be minus 16. So you can factor out the 2 if you want to. It doesn't really make a whole lot of difference. We can just run this through the quadratic with a is 2, b is 16, c is negative 16. And here we get x is approximately 0.899 or negative 8.899. Okay. All right, so that's problem 18. Let's look at problem 20, and then that'll do it for the first half of section 1.9. Okay, so problem 20. We start out with 10 over a plus 1 plus 3 over a minus 2 equals 2. All right, so we're going to do the same thing as we did on that last problem. We're going to just call that 2 over 1. Over here, we're going to make a common denominator, a plus 1 times a minus 2. So that means this will get multiplied by a minus 2 over a minus 2. And this gets multiplied by a plus 1 over a plus 1. So in the numerator, we'll have 10 times a minus 2 plus 3 times a plus 1 equals 2 over 1. Okay, so this will be 10a minus 20 plus 3a plus 3. So that'll make 13a minus 17 over a plus 1 times a minus 2, and then this will be 2 over 1. Okay, so now we've got it set up the way that we wanted, a fraction equal to a fraction. Now we can cross multiply. 13a minus 17 equals 2 times a plus 1 times a minus 2. So this stays the same. Over here, it'll be 2 times a squared minus 1a minus 2. Or 2a squared minus 2a minus 4. And then we'll move everything over here. So these cancel, and we get 2a squared minus 15a, looks like plus 13. Okay, and I think that that is going to be factorable. Let's just run it through the quadratic and see what we get. Yeah, 6.5 and positive 1. So x equals 6.5, x equals positive 1, and then we're all set. Okay, so that's it for the first section, first part of section 1.9. So your quiz will have a couple of problems related to this, and then I'll make a separate video for the second half of this section.